Hello, and welcome to today's SEI webcast, Acquisition Oversight for Software Assurance. My name is Shane McGraw. I'm the Outreach Manager here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make today's webcast as interactive as possible, so you can add questions to the YouTube chat area now, and we'll get to as many as we can. We also received a number of questions prior to the webcast, and we will work in a number of them as well. Now I'd like to introduce our featured speakers for today. Dr. Carol Woody is a principal researcher in our CERT division. She leads developing the team building capabilities and competencies for measuring, managing, and sustaining software assurance and cybersecurity for highly complex software intensive systems and supply chains throughout the acquisition lifecycle. Dr. Woody also co-authored the book Cybersecurity Engineering, a Practical Approach for Systems and Software Assurance. Welcome, Carol.
Glad to be here.
Next, we have Mike Bandor. Michael Bandor is a senior software engineer, also in our CERT division here at the SEI. He's responsible for leading teams that enable organizations within the Department of War and other customer organizations to enhance the predictability of their performance and their mission assurance in the acquisition, evolution, and operation of software-reliant systems. Thanks for joining us, Mike.
Thanks, Shane. Looking forward to today's subject.
Me as well. And now I'd like to turn it over to Dr. Carol Woody. Carol, all yours.
Thank you. Mike and I are excited to be here. It's giving us an opportunity to share background that we have accumulated in dealing with software within acquisitions for decades at this point. And we've dealt with acquisitions of just about every size. So hopefully we'll be able to give you our insights and share with you what we're learning in terms of the challenges now and moving forward, especially as we're moving into continuous software deployment. I think that's a growing challenge that we're seeing. And we actually had some questions ahead of the presentation for that. I want to start by giving you a sense of what we see as the software challenge. Essentially, and I'm sure this comes as no surprise, software is everywhere, anything you buy. But what you probably haven't thought about is that it's part of the product. It's part of how the product is built. It's part of how the product is defined. It's part of how the product is managed. It's part of how it's connected. So software is essentially permeating through all the parts, pieces, and activities that we're dealing with. From an acquisition standpoint, you're looking at, how do I manage this? Do I even need to manage it? One of the interesting examples we've seen is that when you look at an acquisition, such as a plane, you don't see software. You see the hardware, that's what's visible. And the software can change multiple times, and what it looks like still doesn't change. And so in some cases, the software becomes invisible. And this is a real challenge. And it's a major risk, a growing risk, because more and more of the attacks and the where software is failing are not being recognized. And this is where we want to push that knowledge out as much as we can. What most people don't really think about is that all software has some level of defects. And our research is showing us that at least 5% of those are vulnerabilities. What does that mean? And that means that throughout your development process, you are building in future risk, and the better you are at removing it as you're moving through, the better operational product you'll have, and the fewer challenges you'll have when you field the system. But with the pressures of budget and schedule as you're moving through development, it's very hard to see that and make it visible as part of the process. In addition, software itself is constructed of many parts and pieces as opposed to being just built for a specific purpose. Even though you might have a systems design that says we've got certain requirements that fit this particular need, in most cases, a lot of that capability would get pulled down from libraries, from existing code that's reused, from servers and other capabilities that are integrated in that handle pieces and parts of that functional need. And all of these tied together carry that same level of defects and vulnerabilities because it's all software. Software isn't a structure that follows physical requirements with restrictions. It's basically an art form in some sense that's written broadly to address a wide range of capabilities, and you can do just about anything in software, but not every product should have you doing just about anything. And so it's limiting what you're doing that becomes the real challenge within the context of what you're trying to build. We also have this mindset about software that it should be free. That comes from the consumer pressures of how the vendors have marketed software as a consumer product. So we're all comfortable working with it in lots of multiple bits and pieces. But that's probably not how we want the software to operate when we're building a major plane, ship, tank, critical infrastructure, the pieces that we want to rely on. We want them to be more reliable than what we're getting in terms of our average Wi-Fi. All of these are pieces that need to be hardened in a way that can't be compromised. Thinking about software a little more in terms of the compromising focus. An attacker basically needs three capabilities. They need the existence of the software with vulnerabilities that they can exploit. They need connectivity so that they can be able to get to it without having to physically be touching the software. And they need to have the capability of being able to exploit it to do something they want it to do. Well, in terms of what's there for vulnerabilities, I checked the National Vulnerability Database, which NIST maintains for us this morning. And at present, there are 337,302 vulnerabilities. This month alone, over 2,000 were added. So I think you can see this growing range of vulnerabilities exists. The connectivity we're all seeing of everything being connected to everything. And the attacker focus can come from anywhere in the world now because we are so widely interlinked. Even air-gapped systems have too much capability in terms of linkages because of the way we can cross that air gap. And the attacker capability is growing exponentially as we increase what we can do with software. We're seeing a major burst in AI analysis that's helping attackers find more vulnerabilities quicker. So we are feeding a lot of that tension in terms of the potential risk that we're dealing with. We also have to look at the reality that all of those parts and pieces that software is composed of are actually being outsourced and brought in from other organizations. Many of these are small organizations that are creating specialty engineering or specialty capabilities. These are not major organizations with extensive cybersecurity expertise. And so this is becoming a growing vector for attacks to come into the organization. And yet we are increasing the number of suppliers and the number of linkages that we are making with software with every piece that we add into our systems. So there is this growing tension of concern. And if we are not working through the life cycle to remove a lot of these vulnerabilities, then essentially we end up with an operational environment that is constantly focused on reacting as opposed to actually supporting our functions. We end up with major gaps in confidentiality, availability, and integrity. And those are the real concerns that we've got into our operational environment. And so frequently I'm hearing, well, we have budget constraints, so that means we really don't have time to focus on the issues around software. I'm also hearing that software is just going to function. It performs. It doesn't wear out, so we don't have to worry about it at all. So the understanding of the existence of these vulnerabilities and the ability of attackers to come after them appears to be missing in many of the acquisition environments. Um, Contractors are not really trained in their acquisition processes to understand that they have major risks they need to be concerned with. Shane, are there any questions so far on this?
Not live quick, Carol, but as you mentioned, we got a couple that came in ahead of the webcast. So we could take one from John here. John had asked, does the software process apply the systems engineering process to software? And let me know if you need a repeat on that.
I think I would like you to repeat that one. I think I got lost you in one of the convolutions of software.
Yeah. Does the software process apply the systems engineering process to software?
In some cases it does, in some cases it doesn't. Software tends to be built from a factory, so it is repeatable and they're integrating a lot of capability within that factory. But software is more of an art form. It doesn't have the restrictions and the constraints. They have to impose certain constraints as they're building the system. And we're seeing that system and software engineering doesn't always understand what constraints are needed. They don't find out until the attackers can make problems in the operational environment because they're not thinking about it well enough in advance. That's something I want to talk about in the next section. So why don't we move on? Relative to that question about the software development process, we really have what we think of as 4 separate swim lanes that operate independently. You have your mission level, which is your program management, your contractors that have this capability that they want to acquire. We need a new plane that has these functionality. We need a new tank that does these things. We need a new ship that supports the mission that we need. That then kicks off a whole step of engineering pieces that will subdivide this needed capability into the various hardware, software, and processes that are needed to create the end product. Underneath that, part of it will be software, which would be allocated to a software factory where your developers would be working with their tools to create the product that you're looking for. And parallel to that, again, we have in many organizations a verification and validation process that focuses on certification to make sure that it meets all of the standards, the policy standards that our organization requires, and even the supply chain structures. But what you're not seeing here is an integration among these. All these different swim lanes are connected by documents, data, and people. They tend to operate very independently. We're also seeing that the software development process itself tends to lag because you're getting your designs and your ideas prepared ahead of time. And then, oh, yeah, we need to build the software, not really thinking about the fact that the building of it is just as important to integrate all of the security concerns and to understand the analysis, as opposed to the certification, um, where you have to react to it. The pieces in this swim lane are also managed by four different groups. So you have program management, I mentioned earlier. You have systems engineering that is looking at the overall product and how the pieces need to be put together. They're allocating part of that to software engineering, which is using entirely different practices and pieces to put the software together, which I alluded to earlier in terms of how that's built. And then you have cybersecurity engineering that is looking at the overall integration of these pieces in terms of making the final product secure. But in many cases, the cybersecurity engineering isn't understanding the kind of risks that may come out of the software construction itself. They're looking more at what the outside environment influences and connectivity is addressing. So we have potential gaps here. The gaps continue with the fact that each one of these is really looking and prioritizing on a different set of measures. Program management is looking at cost and schedule. Systems engineering is looking more closely at the design and the constraints within the design, for functionality primarily. They don't necessarily think about the overall security issues. They delegate those to cybersecurity engineering, who is not really aware of the details of the design and as it's changing. This gets more challenging as we move into faster, more agile development in both the systems and the software engineering, because we don't have a tight integration among these four different areas. And so the potential for disconnects is huge. And usually that is affected in terms of the early requirements that are not carried through well in terms of figuring out what risks are critical, until we get to the operational environment, because software is not going to break until you implement it. But when it does, it can be catastrophic. So we're looking at a lack of knowledge in these early areas, especially around program management and systems engineering, in terms of why software can be a risk. Too frequently, they're assuming that there are no risks because once we've tested it, it's going to work and it's not going to wear out. But that's not true because there are more and more vulnerabilities that are coming online. It's also unclear who's responsible for handling the quality of the software and making sure that the vulnerability management is in place and is effective. And a lot of specialized testing that would show up in the software side is expensive, time consuming, and there's pressure from the management level to bypass those. We don't need that. We know we've got this under control. We've got things organized, and in reality, there are gaps. What we're also seeing, if you look at the opportunities for when you can address a lot of these early design faults and even development faults, you can find the development ones with the tooling that you can put into the pipelines. So there is an advantage of moving to a software factory and fix it as you find it. It's a much lower cost, but we're seeing that the design issues in terms of what is connecting to what and how it's connecting and how that software is being structured. Also, the supply chain pieces tend to come in these early decisions. All of these represent opportunities to reduce vulnerabilities at low cost that in many cases are missed because of the pressure to move through and get to the final product faster without thinking about what risks are involved. What we see in the development life cycle is that this prediction and analysis and planning phase at the beginning is critical. You've got to have a strong basis to make sure that you really are just verifying and not completely reworking when you get to the unit testing, integration, and systems testing. And this balance is in many programs not well structured. So that's where we see concerns, and it's primarily around software and the risks that relate to software quality. Mike, I'm going to turn it over to you because I think you've got some important activities in terms of the basis for how this integration needs to work.
Yeah, I believe, Shane, we've got a question online we want to answer first.
We do. We got one from Fenwin asking, how should programs treat FPGA bit streams within the software assurance framework? Are they classified as software or hardware app artifacts? Does that classification affect how supply chain risks are managed?
I always love the FPGA question. I know when we go into a program that has firmware associated with it, we ask the question, are you treating your firmware as software or hardware? And I know in one case, we had two different engineers look at each other and give completely opposite answers, and they kind of were dumbstruck that they gave opposite answers. Basically, firmware is a form of software. It goes in something other than a general purpose computer. There are aspects with software assurance with firmware that are slightly different. I noticed the question talked about the supply chain in particular. So you've got IP cores. You can have multiple IP cores, multiple versions running on that hardware device that need to be addressed. Are you allowed to have more than one version of the software running? Is it from a trusted source? The tools used to build the code that goes onto the FPGA, are those trusted? Are you checking what's the supply chain looking for on that one? In some cases, it may include some code you may not be aware of necessarily when they compile it into the bit streams. So hopefully that answered it. There should be, if you've got embedded code for like FPGAs or ASICs, there should be a firmware development plan, either separate from the software development plan, or firmware needs to be covered under both, under the software development plan. There should be a section on that as how they specifically wish to handle that program.
Well, you also might want to note that you need the expertise that even understands the kind of risks that come in with firmware in several places in the organization.
Exactly. So we're going to switch it up just a little bit here. The work Carol and I and our team's been working on is getting programs to think earlier about software assurance, getting it much earlier into the acquisition life cycles. So as we started looking at the different capabilities that were needed, referred to as pillars in this case, they came down to 5 key areas. We're using the department's definition of software assurance, basically the level of confidence that software functions as intended and is free of vulnerabilities, either intentionally or unintentionally designed or inserted as part of the software throughout the life cycle. There is a lot in that statement, explicit and implied. And looking at that, we went ahead and came up with 5 capability areas. We're going to talk about these separately in just a moment here. So there is a related blog post talking about these 5 pillars that just came out. The link is at the bottom of the slide for anyone that would like to take a look, more information on it. Next slide, please. So the first of the pillars we're looking at is software requirements for software assurance. We're going to look at, we've got a definition that we use for each of these, but how we make the acquisition connection. So the software requirements for software assurance, those requirements to conduct software assurance activities should be extracted from your statement of work. You should have information in there that discusses, okay, this is what we expect of the contractor. This is what the government's going to expect and how they're going to be handling it. And that should be able to be mapped to the software development plan activities, how they're going to implement those, or the firmware development activities, or both, as we just talked about the FPGAs. Your cybersecurity requirements also are related to software assurance, or show up in your program protection plan, and those get mapped from the contractor back into the program protection implementation plan, PPIP. Those expected software assurance deliverables should be addressed in the statement of work. Next slide. Software supply chain risk management. Basically, as Carol showed earlier in the presentation, modern software is more assembly of components with some glue code than it is. We don't write our own device drivers anymore. We don't write specialized stuff. It's okay, I need this library to do some sorting. I need this library to do some fusion, et cetera. A lot of third-party software offers affordability and schedule impacts of, hey, I don't have to write this, so that's great. But the flip side of that discussion is it can create cybersecurity and lifecycle risks that you need to be managed. So you just bought something that you didn't develop, which is fine, but you need to manage that throughout the life cycle of that system while it's still in existence. That means there's going to be patching or updates. There's going to be technology refresh. Some of those third-party packages may have hardware dependencies. And that's not necessarily for the FPGA families. I have seen that in some of the cloud capabilities. So how you treat the vulnerability management of those third-party capabilities is going to be very important. Next slide. Software quality and software quality assurance. From an acquisition perspective, there should be quality reviews going on the developer side that the government should have either participate in or be able to access that information. They got to focus not only on the process, but also the product and make sure it's got sufficient assurance to meet the mission it's supposed to have. You don't want to end up with a case where we're following the process, but we're making concrete life jackets. That is the wrong product. You need to have make sure the software quality processes are there. Gives you some confidence that the quality is being established early and confirmed with the contractor reporting, and flows down to the subcontractors. That the prime has responsibility to ensure the subs are following and performing as they're expected, and that flows back up. Next slide. From a systems integration perspective, you need software expertise to look at things from a system integration. It's just not a system. It's just not a systems engineering issue. There's software aspects of it that need that experience. A lot of program offices have very little software folks on their staff, and that expertise is really, really needed, particularly with the how software intensive the systems are becoming. Needed the system level within development implementation, and look at what are the key software assurance gaps that are happening within the development environment and from the contractor. The milestone reviews as you're acquiring your system. Even under Agile, you need to verify that, hey, you're looking at the proper stuff, that the training and practices are there to support the software assurance successes. Next slide. And finally, the software metrics. Every program likes to collect metrics. You need to figure out how you want to measure things when you need it, and you need to monitor that. It gives you an opportunity for that early identification when it's cheaper to fix things than it is later on once you're in development and test. Those metrics provide an objective way to evaluate that progress, and those should also be identified as part of a metrics program or metrics plan as a deliverable from the contractor. So you can see from the 5 areas, this is not a single function or a single responsibility area. I like to use the phrase that software assurance is a team sport. It very much is. There's bits and pieces that are throughout areas of the acquisition that need to work together. Next slide. And next slide. Good segue. So we talked a little bit about this. Next slide. Thank you. Collaboration between those various areas, because you're measuring your risk to the program, to the acquisition itself, how you're executing, and that's got to be integrated across, and you can't run them in a stovepipe. The collaboration is a very key component to that. The software assurance information, you need to integrate across those various documents we talked about: the program protection plan, the system software development plan, the supply chain risk management plan, et cetera. The software architecture should have some software assurance aspects to it, so you know where it is in the system and how it's affected by these various parts and what may go there. Looks like we have another question, Shane.
Yeah, CPS, government versus commercial. Which group is managing the disconnect better? If it's not the government, how can we close the gap? How can it close the gap?
Ooh, that's a very good question.
I don't think either is managing
I
them that well,
I
frankly.
would say, yeah, I think both are doing a subpar job in general.
Well,
That's on a good day.
they're focusing on different segments, but nobody's looking at the big picture.
Right. And then the commercial side, they're looking, their end goals is not fielding a system for the warfighter. There is, okay, product, get the product out so we can make a profit, answering to stakeholders. Whereas the
Mm.
government side, you're answering to the end users, the program acquisition executives, et cetera. So there's a different impact or focus as a result of that.
Well, we're also seeing a real challenge in terms of this integration over time because we see programs that start small and then grow, and things get parceled out, and people get focused on their own little swim lane, and they lose track of how they even connect to other swim lanes. They don't even know who's doing those jobs anymore. Same is true on both the commercial and the government side, that factoring in who's responsible and how has to be continually upgraded. And this is just going to get worse as we get more into the agile development.
Yeah, I know since we're talking the software supply chain, a lot of programs on the government side look at the hardware side of the supply chain. They know where component X is coming from. They're getting bills of materials. The same isn't true on the software side. Where is that third party component? Where are you getting it from? Where was it developed? What sort of vulnerabilities are we inheriting from using that component? How do we manage that risk? It may not necessarily be a bad thing to use a component, but you have to manage that accordingly.
And
Um,
especially with open source. I mean, it was free, you know?
yes, yeah, exactly. Next slide, please. Some of the work we've done in this area, again, trying to get government programs to think about things earlier from acquisition and then security and the software assurance. We built the acquisition security framework. We went across their 6 areas: the program management, engineering lifecycle, supplier dependency management, support, independent assessment, and compliance process management. There's a link at the bottom of the slide for that. Basically, it's okay. I'm having some issues in program management, so you take a look. So there are questions to be asked. How are you handling X? What are you doing with this? You pick and choose, figure out where your issues are, and you can use it. You don't. It's not 100%, but it gives you things to start thinking about earlier in the programs. Next slide. And
I
I'm going
think
to
I have.
turn it over to, yeah, we're going to turn it over to Carol. She's going to talk about some other areas that we have that will assist.
One of the real gaps that we are seeing, especially in areas that haven't thought about cybersecurity and software assurance and supply chain risk, is that they don't even understand that they've got risks. And one of the things we created was a framework and an analysis approach that helps characterize these so that you can begin early with what is it I want to do, and improve what you know about the system as you're moving forward. Essentially, what you're looking at is how can a threat actor come into the technology environment that I'm building? So you need a picture of what are the pieces and how are they actually going to fit together, not just big black boxes of, well, it's going to move from this component to that component, but how is it linking to the hardware and then the software in that component, so that if the software is third party that's applied to it, where is that risk coming from and how are those vulnerabilities potentially impacting what I want to do? And you're really looking at the data flows because you want to know, do I have sufficient confidentiality if that's important? Do I have sufficient integrity on that data if I'm making decisions and relying on it? Or is it going to be available when I need it? And all of these are impacted by how data is transferred and adjusted as you move through what we refer to these as mission threads. And it may be that it moves from one organization to another. If you're looking at this diagram of the mission thread at the top, the workflow, because you have services that you're using and relying on. So all of those play into where is my data? What am I looking at? And this is a structured way to begin to think about what potential risks could I have, and then how could those be affecting the results that I expect to get. This is going to be a trade-off discussion because you can't fix everything, and you probably don't want to because you've got trade-offs of other qualities in terms of processing performance time. Safety and security are sometimes in opposition. And so you have to make choices, but then you can be aware that there are these risks and I have to manage them. Maybe not directly by removing them, maybe I have to monitor them, other things. This is structured as a 4-step process, and we had the link at the bottom here for you to begin to look at it. But ultimately, you're translating the risks that you're seeing from the software and hardware and how it's integrated in technology into something that leadership can understand and rack and stack against the other risks that they have at the program level, so that they can begin to link these pieces together and do a full risk management and not just program cost and schedule. So that they can begin to look at the technology pieces as part of the risk discussion. There is another capability that we put together to have you looking specifically at each supplier, because you have an opportunity when you select a supplier to really look at what are their capabilities for producing a product that would meet the risk levels that I need. Do they have secure capabilities? Can they build the software effectively? Or am I really taking their risk on as part of mine? And I'm going to have to do something to mitigate that risk as I bring their product into my environment. Look at the specific product itself. What are the vulnerabilities that I'm potentially accepting, and how am I going to deal with that? Look at the transmission process. That would involve not only the transmission of the initial software, but updates and patches, because we've seen the patch process being compromised. So we have to look at how can I make sure that what I'm getting from this supplier is going to not impact the safety and security of my product and my environment. And then how am I actually using it? Is it built for a certain level of integrity and structure, and I'm using it differently, in which case I may have to compensate. But all of these are bringing up potential concerns that could surface the gaps early enough that I can address it, rather than looking at it when I have an operational disaster and I'm trying to figure out what do I do. Essentially, and this gets to the ongoing process that you're dealing with. We have to look at, from a supplier perspective, evaluating and then re-looking at it over time. And this would apply to open source as well. It's not a set and forget process, because all of the parts and pieces are changing over time, including the business capability and how you're using it and what you want it to do. And so a monitoring capability needs to be in place. It's got to be part of your normal way of doing business. Gee, I've got to check on my software to make sure that it's handling it. And that's really true for all of the software that you're dealing with in your system. Before I move on, Shane, are there any more questions we need to handle?
So, Carol, yeah, we did get one. Robert was asking us if we could talk a little about understanding the concerns and challenges of software integration during measurement and analysis. I know that pivots a little bit, but is that something you guys can touch on?
Well, certainly you want to touch on the fact that you need to understand that each component piece has to have a certain level of assurance, that you've addressed the vulnerabilities at the lowest level. But once you start assembling these pieces and putting them together, then you have to be looking at what added potential vulnerabilities am I providing for the attacker as I put these pieces together, and there's suddenly more capability that an attacker can leverage. Um, a lot of this involves a different kind of testing from what's usually done in a system. Most of the time, the functional testing focuses on determining that things will work as intended. But for good software assurance, you really want to be looking at, how do I make sure it's not doing something I don't want it to do? And that involves thinking of your requirements from a different perspective. And it involves setting up tests that verify that if I don't want someone to be able to trigger this capability or take this offline or make some other error there, that I've got a way of confirming that. One of the techniques that we've seen being used is fuzz testing, where you're throwing all kinds of data at any level that will see if you can break the system or take components off and see what that does to the system. How do you recover? Because ultimately, you are going to have issues to deal with in the operational environment because you can't get rid of every risk. So the faster that you can recognize, resist, and recover, the better off you're going to be. And that should be built into your thinking, your processing, and your verifications as you're moving ahead. And some of your time lags may be built with the fact that you don't own that piece of code. A supplier owns it. So what are you going to do in the meantime before they fix their bug? All of those become issues that need to be planned for. There's nothing insurmountable about any of these, but you need to think about them.
Yeah,
Anything else, Shane?
to
Oh, go ahead.
piggyback on what Carol said, a lot of the things that she pointed out are measurable, and they can show you some trend analysis of, okay, am I getting better? Am I getting worse? What's going on with this particular function or capability that it's all of a sudden trending the wrong direction that we expect it to. Some of the things are basic software, what I call software engineering 101, your requirements traceability, your traceability of the architecture, your defects, your test coverage. Some of those start to build up bigger and bigger pictures of the assurance of that system.
Well, there's certain techniques too that you can drop back and use there. Um, Zero trust is one, so that you work on eliminating the potential of having untrustworthy access by verifying everything. But not every step can necessarily afford to go through all of that re-verification. Again, you're playing trade-offs between performance and processing throughput, and how quickly decisions need to be made or actions need to be taken within the system. So all of these involve good engineering judgment as you're moving ahead. And you want those engineers to be just as aware of the software risks as they are of the potential hardware and functionality risks.
Thanks for that, Carol. We do have some more questions, but we can let you guys get through your slides and then we can wrap up with some at the end, if that's okay.
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 What I want to emphasize here in the next steps is that essentially you have to include planning for the software attacks because of how software is built, because of how it's used, because of its proliferation in everything. And you need to structure a way to identify and train the people that are making your acquisition decisions so that you know you're getting the best knowledge, and also structure your processes so that they include the right level of collaboration. Obviously, each one of these areas has their own performance activities that they have to do at the program level, at the system engineering level, software, and cybersecurity. But it's got to be integrated so that you know as you're moving forward, you're moving toward this integrated view of your final product that's going to support what you need. What we have put together are foundational pieces that need to be part of that preparing so that you are effectively establishing your requirements. You are effectively monitoring your suppliers. You are identifying the level of quality you need, and you are reviewing it and making sure that all the pieces are supporting that as you're putting them together. You're identifying your potential integration risks and evaluating how you're dealing with them. And then you're monitoring, and you've set up enough metrics to get enough information from your contractors and suppliers and their suppliers so that you know the data is supporting your expectations. We're seeing in many cases that the right requirements were done, but no monitoring and metric support has been implemented and integrated. And so we end up with this software product that doesn't satisfy the quality requirements because no one realized that they needed to do that level of monitoring of their suppliers. But in reality, it's all got to be put together, and the risks that are real with software are going to be experienced by the owner of the system when they implement it. And that's when it's very, very expensive to fix these problems. Whereas if you can identify them early, it's much cheaper, much easier to get the right players at the right time to get the problem addressed. And over time, especially as we're doing incremental, we have to have monitoring capability so that we can identify when things have changed enough that the risk profiles have changed. How do we need to update what we're doing? How do we need to verify that we're seeing a problem over here, that somebody who's made a decision in another swim lane is cognizant of those issues and working with us to address them? So I think at that point, we've provided as much advice as we can, but we're happy to answer more specific questions.
Thank you for that, Carol. Yeah, we can kind of jump into a rapid fire one here, kind of jumping on to some different topics. Kay had asked, how do you implement CMMC and SBOM, software bill of materials? So, Carol and Mike, would you like any advice for that
Mike,
one?
I'm going to let you jump on that since SBOM is an area you've been digging into.
Yes, I can talk to the SBOM side specifically. The SBOMs are, well, relatively new within the last few years. The concept's been around for years. There should be SBOMs coming from the development organization for each of the builds. The third-party component should be SBOM out there. So again, you're managing your risk. What the secret's in the sauce? Well, what's in the sauce? That's what Carl with the questions that the SBOM answers. And then you can, if the SBOMs are complete like they should be, and they've been verified, you can go ahead and start doing some supply chain analysis and risk analysis. Say, hey, I've got a component here that we might not want to use that one for various and sundry reasons. Or I've got a newer component that has fewer vulnerabilities. It's time to go ahead and migrate. You can also use some of that, the licensing information tied in with the SBOMs. We actually did a variant of the acquisition security framework called the SBOM framework. It's also published out on the SCI website. It starts with the fundamental question, okay, I have SBOMs. Now what do I do? Same approach we did with the acquisition security framework that, okay, start looking at from program management things you might want to ask and configuration management things you might want to ask. Also, the SCI, at the request of CISA, did an SBOM plugfest to try to address the question, if I've got different SBOM tools and I run it against the same code set, why do I get different results? And some of that was interesting. That's actually out there in the public that was posted, and some recommendations on how to improve the quality of the SBOMs and why you may be getting more data from one tool versus another.
We've also seen that you can begin to use the SBOMs when you're evaluating legacy to say, is legacy providing more vulnerabilities that I can't repair because I don't have the capability and the knowledge? And maybe it's time that I have to restructure that to improve the risk profile of my system. So all of these are trade-off discussions that SBOM can be a component of the data that helps you make those choices. Not specific so much to CMMC because that depends on how your organization is addressing that review, but it does become a piece of the data that can support that you are appropriately addressing the risks, and that's ultimately what we're trying to achieve.
All right, question. We're going to point this one to you, Carol. Saeed had asked maybe if you can maybe recommend some best practices for cybersecurity and software development. Any resources you can point to?
Well, we've done a lot of work in the area of coding standards, and that information is out on the SEI website. It's important to be building your code with good coding standards or use languages that are more appropriate that reduce vulnerabilities. And that's basically the starting at the base level. When you're actually looking at management practices, we've got several references, and I believe there's a link for assurance references, Shane, that we had talked about that maybe you can share that gives you a picture not just of the specifics that we've mentioned here, but several other webinars and overviews of how you can begin to look at I'm starting here. How do I improve my capabilities as I'm moving forward? You can use the acquisition security framework to do that, to say I'm going to implement certain practices and then I'm going to augment it to move ahead so that you're always improving. The key is to really understand your risks. What we're seeing more in terms of the real challenges with software is that software risks tend to be totally ignored. The software engineers are identifying risks into a write-only database that goes nowhere because it doesn't match up with how systems engineering and program management thinks about risk. And so they don't assume that they're a problem because they don't match a cost and schedule risk. But ultimately, they become an organizational risk, which makes them actually more critical than some of the programmatic risks. But they don't tend to get factored into the design and analysis just because of the way we manage acquisitions and because of the knowledge of the people that are doing that management. Many of them are not trained in software. They don't understand it, and so there are no risks as far as they're concerned because it's functioning, it works. Well, but it probably doing things you don't want it to do as opposed to just meeting your immediate needs.
Another question from Fen Wen asking, in practice, how have programs handled software assurance for legacy systems when the original HDL firmware source or schematics are gone? Are there frameworks that address the gap specifically?
I haven't seen frameworks for legacy, although we've been exploring that with a couple of the groups that we're working with the Air Force. What we tend to see is they treat it like a black box, and assume that it's going to function unless it breaks. If it ain't broken, don't fix it. And that's probably about the worst thing you can do, but that does tend to be the mindset. It's working, so why would I bother with it? This is where if you have metrics that are giving you some perspective of how it's actually performing, then you can begin to justify going in and making changes. But that may mean you have to hire some skills that can go after it. In some of our analyses, when we've gone in and dealt with legacies, we've had to literally go down to wiring diagrams to figure out how the operational pieces are glued together, to figure out where an attacker could get into the system. That takes a certain level of expertise and patience that not everyone is willing to bring to the problem space. But it's the realities of what we're dealing with because we've got all of this software that's floating all over the place in various levels of um, knowledge, expertise, and capability.
Maybe we can squeeze in two more. Jim had asked, can we talk about mitigating the risk of cyber threats due to vulnerabilities associated with outdated software and utilities? Can someone touch on that?
That kind of gets into your license management for those and your SBOMs. Monitoring that information is going to be somebody's job almost full time on a not very large system. I mean, you start getting into the much larger system of systems, you might have to have a team doing that. But yeah, that's somebody's got to be watching that all the time. I know I ran into one system that they identified, oh, I've got this certain package we depend on. It's gone end of life. They tried to replace it and weren't aware of the other dependencies, and the upgrade crashed on them. And they started figuring, oh, well, the upgraded, I needed to do this. And oh, by the way, there's a hardware dependency they weren't aware of either. So that's part of that gap that SBOMs help fill.
Thank you for that.
We're also seeing a tendency when compliance certifications are involved that people turn a blind eye to the vulnerabilities and the legacy because it's going to take so long to recertify the product if they make a change. That I think is ending up being a time bomb that we're just waiting for it to blow up on us. If you're going to have software that has to go through these certifications, then part of your planning has to be how do we deal with the monitoring and management problems, the identification and addressing the risks. Just knowing they're there isn't necessarily sufficient.
Thank you both for that. We'll wrap with this one from Juan asking, how can we maintain software assurance in acquisition in a world that is currently being heavily saturated and influenced by AI development? Carol, Mike, want to start with that one?
Well, I think the attackers are having a great time with it because it's giving them access to a wide range of things they couldn't have found on their own. Especially when you're looking at open source, they've got the code sitting right there that they can play with it. They don't have to go into anyone else's systems and find the IP. Our reliance on open source is a big gap there. And our reliance on open source blindly is a bigger gap. The open source community is actively trying to get organizations to feed back the problems they find and fix them so that they can share the improvements over time as well. I think we've got a lot of opportunities here that no one is exploring because everybody's sitting in their own little swim lane, just doing their own little job and not really looking at the bigger picture. But that's going to take a change in perspective.
Right. There's a lot of articles talking about AI generated code, and it may be semantically correct, but it will not be free of vulnerabilities. And that's still something that's going to have to be trained up. There was a recent article talking about one AI platform finding a lot of vulnerabilities in one of the browsers that went undetected. That's a potential use of AI to do some of that examination now. Trust but verify. The statement applies in with the AI systems that it may have found stuff. You might want to double check to make sure that is what was reported correct, or is it having a hallucination?
And your suppliers need to be willing to make the corrections as quickly as possible because these things can be exploited once they're discovered.
Carol, Mike, great discussion today. Thank you very much for sharing your expertise.
Glad to help.
And lastly, we'd like to thank you all for attending today. Upon exiting, please hit the like button below the video window and share the archive if you found value. Lastly, our next webcast will be March 18th. And our topic will be Software Acquisition Go Bag, cracking the CNS code. Registration information is in the chat area now and will be emailed out as well. Any questions from today's event, please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.
Take care.
Bye.